Okay, we have this proportion and we need to determine if it's a true proportion. Basically, is this two equal ratios that we have here? And so the way that we can determine that is we can cross multiply it. If we cross multiply it and it comes out as true, we know it's a true proportion. So we just multiply straight across 5 and 24. We get 120. And we want to see, does that equal 16 times 8, which is 128? These are not equal, so that tells us this is not a true proportion. These ratios are not equal, so proportion is not true. Okay, often we use proportions to solve for an unknown variable. So we have these two ratios that we know are equal, and we can use cross multiplying to solve or to figure out what this missing variable is. So we do the same thing. We're just going to cross multiply. 4 times x would be 4x equals 8 times 8 is 64. Now this one we know is true because we're told this is a proportion. So when it's a proportion, you can cross multiply and you know that those ratios are actually equal to each other. Okay, so we have 4x equals 8 times 8 or 64. We're going to just divide by 4 and solve. So 64 divided by 4, x equals 16. And if we put this in over here, you can see 4 over 8, 8 over 16 would both simplify to 1/2. So we can see once again that is a true proportion. Okay, here we have another proportion, n over 0.5 equals 2.7 over 4.5. The decimals might look a little more intimidating, but we're going to solve it in exactly the same way. Since we know it's a proportion, we're going to cross multiply it. So we have 4.5 times n equals 0.5 times 2.7. So 0.5 times 2.7 is 1.35. Oops, that's a 1. 1.35 equals 4.5n. We're going to divide both sides by 4.5 so we can isolate that n. And I think that's going to be 3.3. So n will equal 0.3 for our final answer. So notice we're still using cross multiply. We just want to, make sure we're careful to put in the decimals, but we still solve using the same method. Okay, what do we do in this case? We have an 8 is just equal to the 48 over x. So one side is a fraction, one isn't. Well, can we make this a fraction? We can. We can just put it over 1. It doesn't change the value. 8 over 1 is still equal to 8, but it gives us a fraction to work with. So we can say 8 times x equals 1 times 48. So 8x equals 48. Again, divide by the 8. 48 divided by 8 is going to equal 6. Okay, here we have x over 14 equals 8 over 13. So again, we have a proportion. How do we solve? Well, we're just going to cross multiply. So every time you have fraction equal to fraction, you know that's a proportion. So we get 13x equals 8 times 14, which gives us 112. We want to solve for the x, so we divide by 13 on both sides. Now, I'm just guessing, I don't think this is going to turn out nice, and I noticed here it said round to the nearest hundredths place. So, and it looks like, see in the answer, it's 8.615. So I know 1 is the hundredths place, so that's kind of my cutoff. 5 is going to decide, does 1 go up or stay the same? Well, since it's at least 5, it's going to tell it to go up. So our answer then, rounded to the nearest hundredth, would be 8.62 for our final answer. So you're just solving it the same way, but on this one, just be careful that you round correctly. Okay, for 17, we are dealing with a fraction. So it's 9 on the top, 5/11 is our number on the bottom, equals 2 over n. So what's this going to change? It's actually not going to change too much. We're still going to cross multiply it. So we'll end up with 9n equals 2 times 5/11. Now I'm just going to put the 2 over 1 so I can multiply this out. So I'll get 9n equals 2 times 5, which is 10 over 11. I need to divide by 9 on both sides. If it makes it easier, I can even think of it as timesing by 1/9. since I know I've got a fraction over on that side, because that'll make the 9's cancel. So if you want, when you have a fraction on one side, you can always multiply by the reciprocal just to make it easier over here. So we multiply by 1/9 over here. Those 9's cancel. We end up with just n equals 10 and 9 don't cross cancel, so this is just going to be it. 10 over 99, and that's going to be our final answer. This one we don't want as a decimal. Usually when the problem is given to you as a fraction, your final answer will also be as a fraction. Okay, we know we need 1 1/4 cups of sugar, so I'm just going to write this, to make 20 cookies. Okay, to make 8 cookies, how much will I need? Well, when I'm setting up my own proportion, the most important thing is that I put the same units in the same place. So for example, this was my sugar up here, or my cups of sugar, and this was my cookies down in the denominator. So when I set up this other ratio, I better have cookies in the bottom and sugar in the top. So I know I'm trying to make 8 cookies, so I'm going to put that 8 down here because the 20 is down here. I don't know how many cups of sugar, so I'm going to put this in the same spot the sugar is in the numerator, put it up there. And now I can just solve. So I'm going to cross multiply it. I have 1 1/4 times 8, which let's just do a little, turn 1 1/4 into an improper. 4 times 1 is 4, plus 1, we get 5/4. So it's really like 5/4 times 8, just so it makes it a little easier to multiply. Equals, we'll put the little arrow there to show how we change to 5/4. Equals 20 times x. So we go ahead and multiply. Let's put 8 over 1 since we're dealing with a fraction. Let's cross cancel. I love to cross cancel if we can. I can see that 4 goes into 4 once, 4 goes into 8 twice. So I can multiply now. 5 times 2 is 10 equals 20x. We'll bring that up here. 10 equals 20x. We still want to solve for x. So even though it might be tempting to divide the 10, I know I've always got to divide the number in front of the x. So I'll divide by 20 on both sides. So x is going to equal basically 1/2. I can divide by 10 on both. So does that make sense that we would need 1/2 cup sugar for 8 cookies? Yeah, I think that seems about right. If 1 1/4 is needed for 20, 1/2 seems about right for 8. So again, most important thing here is when you're setting it up, make sure your units are in the same place. So we had sugar in the numerator here, so sugar had to be in the numerator here. Cookies were in the denominator for this first ratio, and cookies have to be in the denominator for the second ratio to form the proportion. Okay, this is our last problem. I actually wanted to do this one, 23. So we have a leaking pond loses 20 gallons of water in 36 hours. How many gallons of water will it lose in 17 hours? Totally a real life problem that you could have to figure out. So I've got my 20 gallons of water in 36 hours. So remember, important part, the reason I'm writing the units here is so that when we set up this other ratio, that we make sure hours are in the right spot and the gallons of water are in the right spot. So we need to know how many gallons of water will it lose in 17 hours. So I'll put my 17 hours down here. We don't know how many gallons of water, so we'll just put that as x, and then we'll cross multiply it. So we have 20 times 17 equals 36x. So 20 times 17, we're just going to get 340 equals 36x. We need to solve for x, so divide by 36 to isolate that x. And we get 9.4444. Repeating. Okay, so we need a round answer to 1 decimal place. So it's going to cut off here. I can see that 4 isn't big enough to make this 4 go up. So my final answer will just be 9.4. Okay, good luck.